In this video, I will show you how to handle rotations. So far we are rotating on the x-axis. Now we would like to add one more rotations, and that will be around the y-axis as we are moving left or right. So we are moving in the horizontal direction. Okay, so that's for this video. Let's get into it. What rotation we want to apply when we will be moving horizontally? Let's take a look at this. Click at the player and we'll be moving the horizontally, so left or right. We would like to adjust the rotation on the y-axis. So go to your player up here, the y rotation, and try to adjust it. You can see that's the rotation and the y on the y-axis. Okay, so when the player will be moving at the x direction, right or left, at the same time will be increasing y rotation. Okay, so just a really small change. It shouldn't take that long to implement this. Okay, back to our code, and let's handle it. So I will be handling this in our handle rotation. First, we need to keep the track if we are moving the horizontally, but because when we will be moving horizontally, then we want to rotate. So create here a new bool variable up here, private bool m underscore, and call it is moving horizontally. Is moving horizontally. Initially it will be false. When it will be true, go scroll on the bottom of your file, move to lane. It will be true when we are moving to lane, so it will be true here. And when it will be false again, it will be false again when we will reach our target position. So this check we can write up here in the update, as we have here update. We can write here if math f dot approximately. So if our current position x position, so transform position x is approximately same as our m underscore target position x, then we have reached our destination, and is moving horizontally will be false. So m underscore is moving horizontally will be false. We can try it out. So debug log and is moving horizontally, so we can actually see it. Okay, let's get back here. Notice the console log, your console, and you'll see initially it will be false. It's false. When I will be moving left and right, it will become true for a brief of a second. As I will reach my target position, it will become false again. So it's true only when we're moving horizontally. Okay, and in that time, while we are moving horizontally, we want to adjust the y position, the y rotation. Okay, let's shut this down. Back to our coding editors, remove the debug log, and we'll go into the handle rotation. First, I will keep the track of my target rotation of the x and y, as I'm rotating on the x rotation and as I will be rotating on the y axis. Okay, so I want to keep the track of it. Okay, up here again, create new private float and target rotation x, m underscore target rotation x, initialize to 0, and I mean, actually don't need to really initialize it because it will be by default 0. And the same do for your y rotation, so target rotation y. Okay, when we have these two rotations, actually we have some issue because we have it twice, twice, like this. Okay, get back to your handle rotation here, and we will be now doing some changes here. So this rotate, actually we can remove. We'll be handling the rotation differently. Rotation amount we will still keep. This we need. We'll make here first check if we are moving horizontally. Okay, so let's add here m underscore is moving horizontally. So when we are moving horizontally, we would like to reset our target rotation x to the 0. So m underscore target rotation x to 0. Okay, and we'll be increasing the target rotation y. M target rotation y plus equal rotation amount. And similarly, but in a different direction, when we are not moving horizontally, then we would like to reset our y rotation. So right here, rotation at the y-axis will be 0, and we'll be increasing the x direction. Okay, so here we'll be increasing the x, not the direction, but the rotation. So target rotation x plus rotation amount. Why we are doing this? Why we are resetting it to zeros here? Because imagine the following the case. If we will be rotating on the x-axis like this, All right, like let's say this angle here, well, because we are rotating very quickly, right, around the x-axis, and then we'll start now moving to the right or left. Let's move the right or left here. Okay, we will start doing it. Then we'll start rotating at the y-axis. So let's see what will happen when I will now rotate y-axis. The rotation will look like something like this. And that's I don't want. Okay, I don't want to do it this way. So rather, before I will start moving horizontally, I will reset the rotation back to 0, like this. So my rotation will look like this. Okay? And similarly, when I will start rotating back at the x-axis, you can see that will be create this. Before I will start to rotate like this, I will reset y back to 0, and then I will start rotating the x. I think it will look better, but of course, that's up to your preference. I will reset my positions as I had them before. So let's get our initial as we had it here. So that's our initial values for our cube up here. Okay, and now we can finally apply the rotation. So get back to your code. Okay, handle rotation. So we'll do it like this. We'll write here quaternion because the quaternions are 4 rotations. Write here target rotation. Target rotation. Okay, we'll now construct our rotation. Will look like this: quaternion Euler, like this. We'll provide here target rotation x, so m underscore target rotation, not position. Make sure you're not writing here target position, but the target rotation x. Then target rotation y, and at the z we are not rotating, so 0. So that's the target rotation in which we want to get to. Okay, so x, y, and z0. Okay, now we just need to apply it, and I need to format this better. This needs to be to the right side. Okay, so we'll do it like this: transform dot rotation. So now we'll be applying the rotation, and this will be quaternion dot slurp. So what is a slurp? Just an interpolation, so the rotation will have some smoothness to it. Okay. And now I will say here, we want to go from our current rotation, so transform rotation, which is our current rotation, into the target rotation. And now we would like to get there over some time. Okay, and what will be the time? So this will be our time delta multiplied by our target our rotation amount, or rotation multiplier rather, like this. Or we can, since we are multiplying here rotation multiplier and delta time, we can actually, I think I can provide here multiplied by rotation amount. And this way we don't need to multiply the time delta additionally with the rotation amount, because the rotation multiplier is already multiplied here. So I can just write it this way. Rotation amount. Okay, so that's basically, then we need to just check it out if it works. So let's save this. Back here, let's see. Okay, we're rotating still the x, and yeah, we're rotating at the y now as well. Okay, yeah, works for me. Okay, I'm happy with this. Of course, this could be, as well as everything, improved to your preferences. But so far, so good. I like that we are rotating a little bit right or left. If you don't like it, just don't apply these changes. If you don't like that we're rotating to the left or right, and you want to keep just rotating at the x-axis, completely up to you. Okay, but I will leave it this way. So you have also idea how we can rotate on a different axis. Okay, that's gonna be it from this video. Cheers.